So again, this is the second part of section 4.1. In the first part, we talked about the quick way to find the derivative. You take the exponent of the variable, multiply it out in front, and then the new exponent, you just decrease the old one by 1. So what we're talking about today is just using that, but we're going to kind of apply some of the ideas that we talked about in Chapter 3 when we defined a derivative. Now remember, the definition of a derivative, it is the instantaneous rate of change, which graphically it means it is the slope of the tangent line at a certain x value. So we're going to apply some of those same questions that we talked about then, just using the quick way to find the derivative. So this problem says, find the slope of the tangent line to the graph of that at an x value of 3. So first thing we're going to do is rewrite function f. So it's 3x to the fourth minus 2. When I say rewrite it, I want it so it's every single term is just a power of x. So this is plus x to the negative second. All right, I don't want that variable in the denominator, so I'm going to bring it to the numerator, but that makes it a negative exponent. So now, the derivative, this is where we apply those rules we talked about yesterday. So exponent multiplied out in front, that makes this a 12x, decrease the exponent by 1, so it becomes a 12x cubed. The derivative of a constant is 0. This becomes minus, we bring this exponent of negative 2 out in front, decrease the exponent by 1. So a negative 3. Negative 2 minus 1 is a negative 3. So this is the value of our derivative. We want to know, or this is the equation for our derivative. We want to know the slope of the tangent line at an x value of 3. The derivative is a function that gives us the slope of the tangent line at a certain x value. So we're going to do f prime of 3. So we got 12 times 3 cubed minus 2 times 3 to the negative third. All right, 3 cubed is 27 times 12. Ugh. Why did I choose this equation? Let me get the calculator out. Minus 2 times 1 over 27. So on the calculator, 12 times 27, 324, minus 2 27ths for a grand total of 323 and 25 27ths. That is the slope of the tangent line at an x value of 3 for that graph. That's kind of a large slope. Okay, but we just found the derivative, we plug in the x value, slope of the tangent line is at that x value. Next type of question says, find all values of x where the tangent line is horizontal. The derivative is the slope of the tangent line. Horizontal lines have slope of 0. So what this means is if we want the tangent line to have a slope of 0, that means we want the derivative to equal 0. Okay, the derivative gives us the function that tells us the slope of the tangent line. So if we want the tangent line to be horizontal, that means we want the tangent line to have a slope of 0, which means we want the derivative to equal 0. So what we got to do is find the derivative equation. So for this one, we're going to multiply that exponent of 3 out in front. That makes this a 2x squared minus 2 times 1/2 is 1, so minus x minus 6. There is our derivative, and like we talked about here, if we want the tangent line to be horizontal, we want the derivative to equal 0. So now it just becomes solving a quadratic that is already set equal to 0. So that means we just got to factor this thing. It's 2x and x. It's going to be 3 and 2. So let's go with a minus 2 and a plus 3 here. That gives us a negative 4x plus 3x. There's our middle term. So that's good. And so what that means is we set each of our factors equal to 0. We get x is 2. We get x is a negative 3/2. Okay, so what you can do is graph the original function, and what you'll see is at these x values, you either got a minimum a relative minimum or a relative maximum at those x values, because that's where the slope of the tangent line is 0. And that is it for day 2. We're just getting extra practice with finding the derivative, but then applying it to slope of the tangent line, whether it's setting it equal to 0, maybe we're setting the slope of the tangent line equal to 5, and then find the derivative setting it equal to 5. But the derivative function gives us the slope of the tangent line. That's the biggest idea of what we try to talk about in Chapter 3. That is all. Bye.